I'm Paul Brierley. I run the Yuma Center of Excellence for Desert Agriculture. I wanted to do a quick introduction. We are a public-private partnership funded by the ag industry, and we're a part of the university, and we work closely with university researchers and try to get them to work on the issues that agriculture has. And one of the first issues that I was given was Fusarium wilt. So it's been 5 years ago now, and we partnered with Dr. Mike Matheron up here in the front. Mike, you want to raise your hand? So, by the way, Mike is retiring at the end of this week. Let's all give Mike a hand. End of the year, sorry. We're having a party at the end of this week, but end of the year. But we partnered with Dr. Matheron, and this year is the 5th year of having field trials. We started with an international conference. Steve Koike, who you're going to hear from today, was a part of that, and others. And we tried to bring researchers and industry together to look at what we needed. And certainly one thing that came out of that was that the trials needed to be the current varieties you're using, current methodologies, everything current, because data on old stuff that you're not using anymore or not doing anymore didn't help. So that was one of the things we started was trials. We did 4 years with Dr. Matheron, and now that he's retiring, a year ago we hired Dr. Stephanie Slinski, who's going to lead the show here today, and she's taken up the mantle for the trials and done this 5th year of trials. And I guess, I did want to make sure that I thank, and I saw Matt McGuire here, and I don't know if Larry Ott's here or not, but Matt from JV Farms and Larry Ott from Gila Valley Farms have provided us, free of charge, the land to have these trials on, and they've farmed them and done everything else, so we really appreciate that. And with that, I'm supposed to remind you there's a survey for today. Did everybody get that survey? If you didn't get the survey, please get that before you leave. We would love to get your feedback. So with that, I'm going to turn it over to our Director of Research, Dr. Stephanie Slinski.
So that'll happen. The field visit will be early December. We haven't scheduled a date yet. Got to work with Matt to find a good time when it's, won't be wet again from irrigation or anything. So what this alternative event gives us is more time. So we have several speakers, and they have plenty of time to answer all your questions. We can have a discussion about research needs. There's a great opportunity for us to discuss Fusarium wilt and the problems that you're having. That's pretty much my 10-minute introduction there. So I'll just move on to our first speaker, and we are lucky to have Steve Koike here again. He is the director of TriCal Diagnostics in Hollister, California. Many of you know him already. He and his staff operate a plant disease diagnostic lab. They test for pathogens, conduct research on soil-borne and foliar pathogens, and provide plant pathology and crop production information to clientele who grow and work with various agricultural and horticultural commodities throughout and beyond California. So, Steve, thank you so much for being here.
Well, good morning, everybody. While she's picking up my talk here, Mike, congratulations.
Thank you.
But you're too young to retire, I thought.
Yeah,
so,
right.
really, congratulations.
I'll pay you later.
Okay, yeah, exactly. Thank you. Great. Well, first I want to thank the YCEDA group and Paul and Stephanie for inviting me to participate this morning. Of course, we all had different plans, but so what I'd like to do is very briefly give you just a few minutes update on Fusarium wilt in Salinas in California. Of course, for those of you, a lot of you have connections with our state's industry and the lettuce in coastal California, so you probably know a lot of this already, but we do have this problem as well. So I'll give you a real quick update on that, and then I'll show you some pictures because maybe not the same here in Yuma, but in coastal California, we have 2 or 3 other soil-borne problems that are showing up, and they're confusing our PCAs and growers about what's out there, because we have Fusarium, but we have these other things too, and especially this year, there is a whole lot of crop failures. We had a lot of fields where 75% of the lettuce wilted and was not cut. It's because of Fusarium, but other things too. So I'd like to show you those things. You may not have them, but it'll give us cause to be careful when it comes to diagnosing these things and not make assumptions. So that'll be the second and last part of my talk. So first, a real quick update on what's happening Fusarium wilt-wise in California. And again, you probably know this already. probably about a dozen years ago or so, my lab was one of the first to start picking up Fusarium on lettuce in California. And then I started to talk about it at my extension meetings. And one of the, no names here, but one of the very prominent and successful growers in the Salinas Valley came up to me and said, you know, Steve, that was really interesting, but you probably don't need to spend much time on that because, you know, we're never going to see Fusarium in Salinas. I mean, it's a Huron problem, you know, it's warmer there, the soils are conducive. It's a Yuma problem. We don't care about Yuma. That's what he told me. Hence no names, because you would know him.
He probably cares now.
Yeah, he probably cares now, right? No names. But he said, you know, it's a Yuma. It's a desert problem. Don't worry about it. We're never going to see it. Well, I'm here today to tell you it is a Salinas Valley thing. Okay, we do have the issue, and we're in the same boat as you, and that's one of the reasons why we want to collaborate with you and the YCEDA group to look into this. So, couple observations on lettuce, Fusarium wilt in Salinas. Distribution. Again, a dozen years ago, we began to get it in the warmer part of our valley. So if you know our Long Valley, King City, San Ardo, south of Soledad, the warmer part of our valley, we began to get hits with Fusarium wilt on lettuce in that area. Nothing north. And again, those of us in the know, we said, you know, it's going to stay down there. It likes warmer soils. Warm and cold is relative, right? But for us, down there, it makes sense. Fusarium on those crops down there, that makes sense. We'll never see it in Salinas proper and that sort of thing. Well, 12 years later, if I show you a map, we have Fusarium wilt on lettuce throughout the valley. And in fact, some of the worst fields are just due east of the city of Salinas. And these are some of those 60% crop loss things. Way north, for us north, close to the city of Salinas. So distribution-wise, it's all over the place. Started in the south, and I'm sure because of equipment and other things, we've spread it. So it's not a localized thing for us. I'd like to leave you with that information, or that feeling that it's a valley-wide thing, and we're concerned about it. And again, just so you know, we've had our first hit of Fusarium wilt on lettuce in Santa Maria. So Santa Maria, if you know, is a little smaller area, coastal, cool. That also has Fusarium wilt, although it's very limited, and we'll see what happens to that. So that's distribution. Incidence or importance, I'm quoting you those numbers. I mean, we have fields where it's just Fusarium wilt and maybe 60% of the crop is gone. Doesn't make harvestable size. Now that's kind of an outlier. We have many other fields where it's a smaller amount. It looks like a recent introduction. You know how it is in a field where you go to this field and you have a little bit of Fusarium wilt in one corner. I mean, that probably assumes it was introduced there on equipment or something. It's a point source. As the grower moves that dirt and continues to grow lettuce, that corner is going to get bigger, of course. But it's not, we don't have every single field with 60% Fusarium wilt, but we do have some of those. Others, it's much smaller, but it is something that is spreading, and we're concerned about that. So that's the importance of it. Very important for some ranches, and becoming more important. Each year we move that ground, that dirt, and continue to farm lettuce. Which lettuces? I think maybe the same history with you guys. I mean, to us at the beginning, it looked like a head lettuce issue. You know, iceberg was the main thing, or the only thing really getting Fusarium wilt. That's changed. I'll show you a nice photo. I call it nice, you know, pathology-wise, right? But it's a field where romaine is hammered. So I think it depends on the variety. You know, some romaines are much more tolerant. Probably all the romaines are somewhat tolerant. So it depends on the variety. And depends on the inoculum. You know this already from all the research done here and elsewhere. The higher inoculum, if there's more Fusarium in your ground, there's more pressure on that crop, and you'll see more breakthrough. And then the environment. Fusarium is driven by temperature. It likes it warmer. It's more aggressive when it's warm. So if you have warmer temperature that stresses the lettuce, a variety that's maybe a little more less tolerant, and high inoculum, we'll see romaine go down almost as bad as head lettuce. So I have these old extension slides I used to show. We used to summarize that for our growers, and I'd say, you know, plant romaine because romaine doesn't get it. Well, I took that slide out because that's no longer the case. Okay. Then the final thing I'll do is talk a little bit about identification. Now, you here in this region, you're very experienced with Fusarium on lettuce. You know a lot about it. You've got really good experts down and professionals here working with you on that. But I want to caution you that when it comes to diagnosing plant diseases in the field, we should all be careful. We should be careful about your assumptions because you've had Fusarium in this field for 10 years. and you have some issues again, you're going to assume it's Fusarium. I would suggest to you that you don't always make that assumption. Check it out. Be careful about what you're seeing out there, because I'll show you my last few minutes here some bad assumptions from Salinas Valley growers who are excellent growers. We have excellent growers. Our PCs are really good, but we have a development in the coastal area where there are now 4 different soil-borne problems on lettuce, and we're seeing that some plants have 2 or sometimes 3 of these on a single plant. So we're getting multiple infections. I don't know if I use the word complex, as a formal sense, but we have multiple infections. And when you have multiple infections, the lettuce goes down really fast, really severely. So you can look at these fields. I'll show you these pictures. You could say, well, that looks like Fusarium, or that looks like verticillium on lettuce. It could be, but it could be also Fusarium and something else. And on top of all that, if you have your feelers into the news for California, we had horrendous virus issues on lettuce late summer, and that adds another complicating factor to diagnosing these things, because some severe virus problems kind of looks like early Fusarium. I'll show you pictures, okay? So that's where we'll go in my final few minutes here. All right, so I just kind of told you about this. So this is a late season development. Actually, we had a little bit of this in 2018, and I thought, well, that's kind of interesting. If I was a lettuce grower, I'd be unhappy about that, but yeah, that's kind of unusual, not a big deal. Well, Paul, I'm kind of wrong, because it's the second year now. Second year we have this, and I think it's a building thing, and we're talking to the California Leafy Greens Board about, concern for the future, because I think this is a building issue for us. And again, as I go through this quickly, you guys don't have all 4 or 5 of these things. You might have a couple of them. Based on history, we know a couple of them are here, plus Fusarium. So you may not have all these, but I'd like to show you what happens when you have multiple issues that look the same, and then also caution us to not to make too many assumptions, because we could be wrong. So that's the point of this, even though you'll say, oh, Steve, we don't have INSV here. So the point is, be careful. So the 4 soil-borne things, we have a big deal with verticillium and Fusarium. So we have the 2 wilt things. You do not yet have verticillium. So the verticillium, Fusarium, wilt, very important, big deal, long-term survival in the soil. That's our big concern. But in addition to that, we have kind of a building story with this Pythium wilt. It's called Pythium wilt. I'll show you pictures and talk about it when we get to the pictures. The 4th one is black root rot. I know you guys have that. This is Phalaviopsis. It's more commonly known as a pathogen, a root pathogen on beans and legumes, cotton, other things. It's a seedling disease on cotton. So we have these 4 things out there, and symptoms overlap. Then, like I said, on top of that, we're having primarily INSV, impatiens, necrotic spot virus. It's a thrips vectored virus, very closely related to tomato spotted wilt, which I think you have around here. That is causing a lot of problems by itself, and then I'm saying we're mixing this on top of these soil-borne things. And that's resulting in what I would call incomplete or erroneous diagnoses, because growers are saying, well, I had Fusarium here in this lettuce a couple years ago. I'm losing 60% of my crop this year. I didn't realize it could get so bad so quickly. They'd send us samples. It is Fusarium wilt, but it's Fusarium wilt and Pythium, or it's Fusarium wilt and INSV. So it's complicating the diagnosis there. And that's because the symptoms overlap, and you're getting more than one pathogen on any particular plant. And then, if that's not enough for you, on top of that, we have these other things on lettuce that kind of look like diseases, but they're not necessarily. So like physiological problems on lettuce or ammonium toxicity. I'll show you pictures. These things kind of look like a disease, and some growers are saying, I heard all your talks about Fusarium, so this must be Fusarium, right? I'll say, no, that's probably some sort of physiological breakdown of the core, ... So there's other things. It's complicated. So again, in my opinion, you got to be careful with that. So let me go through these quickly. I'll just make a few comments about diagnostic approaches. But again, the bottom line, if you really need to know, you have to have a lab test it. Whether it's us or someone else, someone's got to test it for you. Verticillium wilt on lettuce, you don't have this yet as far as you know. The one big thing on verticillium is to remember it's a mature plant disease. You only see verticillium near the end. If you want to see a grown lettuce grower cry, it's like a beautiful field of lettuce. He's 8 days away from harvesting, and then it starts to wilt like this. It's literally 1 week away, or 10 days away, or 5 days away from harvest. It'll start to wilt. That's a very signature symptom of verticillium. You do not see it early. Infection was months ago, but the symptoms don't show up till late. So this sort of late season collapse, very characteristic of verticillium. This is a field verticillium only, and you can see why you can bring a grower to tears, because this market was hot and he was ready to cut in 10 days, and this is what happens. Very, very severe. There's a survival structure in the corner that allows it to stick around for 5 or 8 years easily in the soil. Cut the plant open. One signature symptom is the core is sort of black, not brown. Although, again, you could have brown and black sort of grade into each other in biology, so you be careful here. But in general, the vascular discoloration is dark and almost a greenish black. That's for verticillium. Now, we can separate that superficially. Again, I don't recommend this without doing a lab work, but superficially you can separate it because Fusarium is not just a mature plant disease, as you know. You can have Fusarium infect lettuce quite early, 6-leaf, 8-leaf, rosette stage. You can have Fusarium on those early stages. This photo is a nice one because it shows this field, which is very mature. These plants in the front row here, they never made very good size because they're infected quite early. But the middle row and the back row, they're also infected. They got pretty big because they're infected late. So I just want to show you that the range of infection and symptoms can start early all the way to harvest. That's Fusarium. You don't see that with verticillium. This is what I was telling you about. This is a romaine field in South County. I took out my old extension slide. We said romaine doesn't get the disease. Well, Mike, we were wrong about that. So I quickly got that slide out of there. But I think based on the variety, inoculum pressure, and stress or temperature on the plant, romaine goes down just as bad, almost as bad as iceberg. So this is, again, not an unusual situation which our growers are seeing. Again, survival structure at the top there, that's why it sticks around for a while. Cut the plant open. In contrast to verticillium, which it's black, right? Sort of blackish. The Fusarium is rarely black. It's more of a brown, brick red color. So when you cut open that vascular tissue and look at it, it tends to be brown to brick red, okay? And this is what I was telling you about with our change in opinion. We said before, this is a dozen years ago now, we used to have the Fusarium just in the South County, the green stars where it's warmer. The verticillium was only in the north, where it's cooler, relatively cooler, and we kind of felt that was going to be the way it would stay. But this is now. We don't have that situation anymore. We have both wilts in the valley throughout the run, north and south. And see, that adds to the complication with diagnostics because we used to tell the growers, well, Steve, I got this wilting plant in King City. I said, well, it's probably Fusarium. Well, we can't say that anymore. It could be verticillium too. Anthony? So Anthony's comment is about these complexes where we have more than one thing involved in terms of a soil-borne problem, and is that maybe responsible for this distribution and this increased range of both pathogens? And from a strictly scientific point of view, I don't know because we've not done research on that, but I think I agree with Anthony that this is probably part of the reason why these things are important up and down the valley, because it's not just Fusarium by itself, it's Fusarium and Pythium, or verticillium and Thalaviopsis. So I think that's true. In a general sense, I think that's true. Okay, the question is about the race. So to be honest, no, we have not looked at the race. We have confirmed the Fusarium oxysporum pathogen for lettuce and the verticillium for the lettuce. We have not looked at race. Other people have. In terms of the verticillium, it's pretty much race 1. Christian and other people we work with have done that work, and it's pretty much race 1. We have not looked at that on lettuce at all. So that's a good question. And again, down the road, when we continue to partner with other people, we can trade isolates and have someone look at that. So that's a good observation.
Again, going back to what you and I talked about in the past, is it's entirely possible that there's been some dynamics in the genetics on this that cause the problem.
Sure, absolutely. Stephanie, I'm okay on time. Do you want me to?
You're fine.
Good, okay. I won't take the time to read this because I'll show you pictures, but just the point is there's a bunch of things that we all should consider when you look at a dying, declining lettuce plant. Sure, Fusarium wilt maybe for you is kind of the main thing, but for Salinas, we can't assume that because there are other things. I'll show you pictures. Other things are involved, and if you go out and make an assumption like that, I think it's risky. I think these days it's difficult, or I should say dangerous to guess. I don't think with the amount of input you're putting into these crops, you can assume that. So here are those non-wilt. These are not Fusarium or verticillium. These are those other things. So upper left, that's systemic downy mildew. You know, you could open that plant, it's black inside. And you say, oh, that's verticillium. I never knew I had verticillium here. Well, you didn't. See, that's systemic downy mildew. Kind of rare, but it does occur. The other two corners, there are physiological things. You guys know better than I do. Weird things happen to the core of lettuce under some circumstances. And some of them, you know, if you're not careful, you could say, that kind of looks like Fusarium. You know, I mean, it's one of those things where it's ambiguous. That's the point. And then this one, I know both our states get ammonium toxicity. You know, under certain conditions, that ammonium builds up when the soil seals and all that. That brick red color in the center, that's identical to Fusarium. It's identical. I can't separate it. Always have to test it. So there are other diagnostic clues with that one, but it really looks like Fusarium. That's ammonium toxicity, not related to Fusarium. And then some common things, again, I know none of you do the windshield diagnosis where you drive by and go, oh, I know what that is, right? We don't do that, do we, Paul? Do you do that here in Yuma? No, you don't do that in Yuma. But you know, the common things, the botrytis crown rot and even sclerotinia, they look similar to some of these other problems. Again, you know these really well, but my point is you can't assume, you know. Because one grower told me, hey, I never knew I had sclerotinia in this piece. Well, he didn't, that was Fusarium, see? So that's the thing you gotta be careful of. Making assumptions. Those are common ones, but the symptoms overlap enough where you have to be careful. This is the one I want to highlight for you because this Pythium has been found in the desert area a long time ago. I don't know if it's a big deal because I haven't heard you guys mentioning it. For us, it's becoming a big deal. So you see this picture? These Pythium wilt fields are very similar to this, where you have significant decline. And wouldn't you agree with me? This kind of looks like Fusarium or verticillium or bad sclerotinia, right? I mean, it looks similar until you're more careful about it. This is another, this is Pythium wilt only. This is one of those, only one in this case. That's enough. Pythium wilt, this is not sclerotinia, not Fusarium, it's just Pythium wilt. The key to this is getting the root out. So our growers, we encourage our growers to give us good samples. I want to tell you, on this disease, the root is really soft, so for a while, people would sample it and they'd snap off that root. And the top part of the plant, we wouldn't find the pathogen. So if you're going to be looking at this carefully, make sure your PCAs are doing a good job with a shovel, not pulling that thing out, and get the whole root. You can see a healthy plant here versus two that are diseased. The main thing on Pythium wilt is discoloration, extreme discoloration of the root. I mean, it's an ugly brownish gray color, and I think you agree this is very different than Fusarium or verticillium or sclerotinia. Note that the crown is intact. It's not a crown disease. The crown is solid, but the root is very discolored. This is Pythium wilt. This is the structure, the spiny oospore, the fungus. This is caused by Pythium insinuatum, and I'll try and go quickly here. This is a different kind of Pythium. This only goes to lettuce. It's a lettuce-specific pathogen. You follow this planting with spinach, which is very sensitive to Pythium, no problem. This one does not go to spinach. Does not go to any of the crop as far as, you know, just lettuce. First described in Japan and the Netherlands back in the 1960s. We have it in California. It's now becoming a big factor in our coastal region where there are a dozen fields that look like that one I showed you. Then the other one, the last one, black root rot, Thalaviopsis. This is an interesting one. By itself, this is a field with Thalaviopsis only. By itself, it does not kill lettuce. It does not kill lettuce. It causes the lettuce to be stunted. It falls behind. It looks more like tractor blight or a skip and fertilizer, and that's what this was diagnosed for a couple years. People thought it was a fertilizer issue. This is Thalaviopsis, black root rot. And it only attacks the small roots, but it makes this very distinct banding. You see this banding like that? Have it checked out, but it's probably Thalaviopsis. And the Pythium causes the whole thing to turn grayish black. Thalaviopsis only bands. And you can see a healthy plant here. The other two from the same field are stunted because of the feeder roots that have been taken out. Okay, and then the last thing, that virus, for us, INSV has been horrendous this past year. It's a fixture in our county. We have it every year, but this year is particularly bad. And I bring it into the mix here because it's causing problems with diagnosis. Because growers would see this and they'll think, oh my God, I've got that Fusarium you're talking about. Or is this that Pythium wilt? You know? So there's overlap of symptoms. And then the other thing is they are having more than one factor. So we have a dozen cases where we confirm Pythium or confirm Fusarium or confirm Verticillium, and on top of that, they have INSV. So there are these complexes of things happening, and again, if you know Slinski Valley, if you have connections there, the late summer lettuce had a lot of problems, and we lost a lot of cartons, a lot of cut because of that. Two more pictures of INSV at the top on lettuce, and INSV goes to other things too. That's spinach, thrips vectored virus. So with that, I'm done. I just want a final thing show you. This is a chart I made for our growers and PCAs, and there's those diseases I talked about on the top. Here are some typical symptoms on the left, and just want to highlight that, with one exception of the stunted size, because verticillium does not cause small plants. I just want to point out that generally a lot of those symptoms are similar, if not the same. And you're looking at a field situation, it's not that simple to diagnose that. So it's one of those things that we do as a part of our service. We identify these and confirm them for sure. But be careful out there. Even though you guys and Yuma don't have all those, who knows, Paul, someday you might. You might, or you'll have something else, right? It's just doing due diligence to be careful with diagnosis, okay? All right, with that I'm done, and I'll pass this to you. Or
Questions? We have time for whatever questions you have.
Yep, in the back.
Are there any immunoassay strips or ELISA strips for any of these diseases that we can just use?
Okay, the question is about quick tests. These immunostrips are a quick test, very nice. For the virus, yes. So there is one for INSV as well as tomato spotted wilt. Not for the others, no. There are ELISA tests, but ELISAs are very cumbersome to run. So, a lab like ours, we do those, but for INSV only. Okay. All right, thank you.
Isabelle is the head of America's brassicas leafy breeding program at Bayer, and she breeds romaine for the romaine and iceberg markets in the United States.
Hi, thank you for having me. I have to apologize since it was originally going to be a field day. I don't have an actual presentation. I've been out in the field all week evaluating a romaine trial, so I apologize for that. But I can give you a little bit of a background, mostly on what our company has been doing for breeding for Fusarium resistance, because each company, we're all going to have a different strategy, and I'll give you just an overview of what we're doing. Sorry, I can't go into too much details, but one thing that is important when you're looking at my history, like Stephanie mentioned, I started breeding for lettuce in Europe. And why is that important? When I started 9 years ago, we were one of the first things that they were talking about, one of the big things that they were saying to watch out for was Fusarium. It started out in Italy, and during my 4 years there, it was crawling up into southern France, and it's been spreading since then. And what we're seeing here is exactly what we were seeing in Europe 9 years ago. And what's nice, for me, is I had the experience of starting breeding for Fusarium resistance when I was working in France, and then when I came over here, one of the first meetings I had here in Yuma was actually the conference that we had almost, 4 years ago on the Fusarium here. I'm like, oh, this is not a new story for me. I'm understanding the story. I know what's going to be happening. And in these last 4 years, we've seen it spread through the Yuma Valley, as everyone has seen. One thing that we've noticed as a company, and some of the struggles that we had, and I think we are overcoming those struggles now, is there are many different sources of Fusarium resistance within all of our germplasms. And it's really identifying what sources have a strong level of resistance. And this is something that we struggled with early on, was a correlation between lab tests that we were having in plant pathology and what we were seeing out in the fields. When I first came back to the US and took over the role here, we were claiming based off of lab tests that we had some varieties that at least had intermediate level of resistance. And then I would go and talk to our salespeople, and they would be like, no, that's not good enough. And so it was really, I think, an understanding of being able to talk with our salespeople and our discovery group and come to like a collaboration on what is a good level of resistance. Because from the plant pathology side, they were saying, yes, we have the resistance, and you can see the resistance. You can see the difference between a susceptible check and what our varieties are saying. But then I would go out to our trials out here, and it would maybe be performing better than the susceptible check, but it would still not be performing ahead and would not be something that you guys could harvest. So intermediate resistance does not mean anything if you can't actually harvest the crop. So we have been working the last, well, actually really the last 9 years on understanding our sources of resistance within our germplasm. And in our company, I don't think it's any surprise that I would be saying that we do have molecular markers for some of our sources of resistance. But I think the most important thing is having a good link between what the lab tests are saying and what we're seeing in the field. So you'll see, especially now the last 2-3 years, we have been making sure that we're putting out the trials in the fields that have really high pressure to see how well are our sources of resistance holding up under field conditions. Because what really matters is what's going on in the field conditions, not what's going on in the lab. And we've had to make some adjustments with the lab to make sure that it's correlating well to what's going on in the field. So I think, you know, every company has their own strategy. And you're going to see different people will have different strategies on what's moving forward. We are really trying to do a strategic approach to know what our source of resistance is. And we've discovered several sources. So we know that if one of those breaks, I'm hoping we'll be able to find it fast enough because we have them out in our trials to see if these sources are holding up. And so far we have some that are holding up, which we're really excited about. But then we do have some that a few years ago we thought were good enough that are starting to die back. So yeah, for me, the big message is that collaboration of just because someone says something's resistant in the lab, the most important thing is what's going on in the field itself and making sure that we are testing in the field and doing a strategic way in order to make sure we're getting the resistance in. And I can answer any questions. I'm sorry, I don't have any presentation, but any questions about how we can, how we're using breeding. And just also another thing to add, this is something with breeding for disease resistance in general. What you're going to find whenever we're trying to breed for a new disease, in the beginning, the varieties are not going to be looking the greatest. Because first we need to get the resistance into something that is somewhat harvestable. Once we get a good source of resistance in, then we can work again on getting that quality back into the variety. And you know, like I've seen this experience like with, for example, with downy mildew when I was working in Europe. Downy mildew in Europe, it's very aggressive. You have new races all the time, so you have to keep on breeding new resistance genes. Whenever you're taking resistance genes, most of the time, they're coming from a more wild type of lettuce or from a different market class of lettuce. And you're bringing it into the new market class, you're bringing it into the iceberg or the romaine. And it's going to take a while to get the quality back up in there. So the first ones always look a little bit more rough, but then this next generations, as we're able to work more and more of the iceberg or romaine genetics back in, it's going to become cleaner and cleaner. So I think that's what you're going to see with the Fusarium for a little while, is that we're going to have things that are going to be holding up, but maybe the ribs are just not quite right. But that doesn't mean in a few years we're going to have things that are improving. And that's the truth with any kind of disease resistance that we're talking about. So, any questions, I'm willing to answer them.
Nobody has any questions?
Can you talk about the time frame of when when they might expect something that's both resistant and marketable?
That's a good question. Well, I can talk more about the time frame that I feel like in our company. Within the next 3 years, we'll have things pre-commercial that I'm hoping will be both with the resistance and with, more of the horticultural traits that we're looking. I would even say I'm hoping 2 years, but I'm going to say 3.
I have a selfish question. So not for you, but just in terms of breeders in general, would the focus be on breeding desert varieties, as for here, in the context of the desert varieties, or would these varieties fit a coastal window as well, or is that completely different breeding efforts like that?
It's completely different breeding efforts, but we're already starting to breed for Fusarium resistance for coastal varieties too. Especially like the last 2 years, we've been hearing more and more about Fusarium problems, and so it took us a while to build a strategy for Fusarium, but now, like, as a company, we have a strategy, and we know we are using molecular markers to track the genes to go in, and we've already started projects to get those resistance genes into the coastal market.
Yeah, no offense to my Yuma host, but we just want to make sure we're not left out. So.
And one thing for the Yuma, and this is, I realized I'm only talking for my company, like we also recognize too that it was starting off as just really the, like September plantings as a problem for September plantings, but now we're starting to see it go later into the season, and we're already starting to be working on varieties that will have resistance for later in the season. Yes.
Once we have resistant varieties, what are the best cultural practice to maintain that resistance so it doesn't become overcome by the pathogen?
That's a good question. I'm not as good of a person to answer that. I think the best practice is, but this is me, like I'm just, I'm a breeder, I'm not a plant pathologist, but keeping your farm equipment clean, I think that's going to help limit the spread of the disease. And like some of the things, I'm not sure if you guys know what's going on in Europe right now, but so Fusarium race 1 has been an issue for the last 10 years in Europe. Now there's race 4, which is also a problem. And so, that's, one of the questions is how can we also identify early on if there's new races coming into the area? And if you do see new races, let us all know, because as soon as we know that there's these new races, we can start to develop our own breeding populations in order to take care of those. Because the difference between, for us, the way that we determine the difference between a race 1 and a race 4 is the varieties that are holding up to those pathogens. So you have different genes that will work against race 1 and different ones in race 4. So, or race 2 or race 3. So if you see already, like you hear right away that you have Fusarium and it doesn't fit the race 1, in a few years, we've seen what race 1 has done here over the last 5 years in Yuma. We know that it can spread quickly. It becomes a bigger and bigger issue. So identifying the issue early on is going to help us seed companies breed quicker in order to give you guys resistant varieties.
I think that's a really good point. Not knowing between Salinas and Yuma and North Salinas, South Salinas, now that's popping up in Santa Maria, not knowing what races are everywhere is gonna make it difficult for people to breed for something like that. If you know what's in each different area, at least you can target with certain breeding lines for that race.
Exactly, yes.
And to add to that, as another seed company, not knowing if it's Fusarium or Verticillium, there's another factor taken into account for breeding, maybe stacking traits, is the next thing for Salinas Valley, especially.
Yep. Yes?
I kind of got the impression you thought that like Europe was like ahead of us on the disease, like it's worse there. Is that actually true, or is it a climatic thing, or latitude thing, because they're mostly farther north, or do you you have any idea of that?
The main reason with Europe, disease resistance is a lot more important in Europe than in the United States, mostly because of the amount of pesticides they're allowed to use. There's a lot less options for the growers in Europe. And so, for example, like downy mildew is a lot bigger of an issue in Europe than it is in the United States because a lot of the fungicides that they use here, they're not allowed to use there. I'm not sure, I do not have enough knowledge about the pesticides that you can use for Fusarium. I don't think that there are very many, so I think that that's just more coincidental that Europe got that before us. But in general, I would say my experience of breeding in Europe versus here was when I was breeding in Europe, I was primarily breeding against diseases. And that was the most important traits was disease resistant, and then after that would be quality. Where here it's first quality and then disease resistance. But I'm thinking like with the Fusarium, it's really the first time that we're sort of seeing that there's an issue where it's so strong that having that Fusarium resistance is more important in some of these markets than whether it's a little bit ribby or not. And this is a first, I think, for the United States. And when I first started breeding for the United States, they actually warned me. They're like, this is not the same as Europe. You know, you need to first be focusing on the horticultural traits, then the disease resistance. But we're seeing with Fusarium, in order to try to catch up, because we have to catch up, we're going to see, like I said before, a little bit of the quality drop for a few years before we get the resistance on it.
This is probably a real bad no-no question, but I'll ask it anyway. Are you doing anything with GMO?
We do not do anything with GMOs.
Is anybody?
Not that I know of.
Or is it even possible in lettuce?
I think GMOs can be possible in almost any of the crops, but GMOs are very expensive to develop. And so the only crops that they're going to be focusing the time and energy to be doing GMOs are crops that they can make a lot of profit because there's a lot of regulation and it's very expensive.
What about gene editing?
Gene editing, so gene editing, some of the universities are working on gene editing, but I think that would be dependent, each seed company might be doing something different with that.
Once you've identified a resistance, a source of resistance, how long would it take to get that into a commercial variety?
The way that, and
What you do it?
the way that we do it, to get into commercial variety.
Yeah, how long between identifying that, that target to actually having something in the market?
Good question. So, well, we do have ones identified, so we're already in the process of this. If we want to go very, very quickly, and this would be very, very quickly, I would say 5 years.
And that's with all your markers and breeding and
Yeah, and not with GMO, not with gene editing. That is doing with all, we're just using molecular markers to assist us with it, but it's not any GMO or gene editing involved. And I don't know anyone who's using for Fusarium resistance gene editing that I've heard of, or GMOs.
Jim McCreight is the location coordinator and research leader for the Crop Improvement and Protection Research Unit at USDA-ARS in Salinas. He's active in melon and lettuce breeding research for 43 years, beginning in 1997 in Imperial Valley. Don't leave. You can't retire. You know that. And his current research in lettuce is combining Fusarium wilt and Verticillium wilt resistance and lettuce aphid resistance.
Good morning. Thank you, Steve and Isabelle, for the nice introduction. I had some slides in my presentation that I wondered whether they were really necessary or not. Now I can help pull the picture together a little bit better. Okay, so this is a field, I think, with Mike Matheron way out in Welton. We had maybe 2003 when we were looking at all these varieties, and Fusarium was really hot. out there. It was a wonderful series of tests. And this is if you haven't made it out to the field trial, this is what it looks like. So you can just hop on the plane and go home. You don't need to go to the trial. So it was rather wet yesterday. We went out and looked at it, and you can see there's what's encouraging is there's a lot of lines out here that look resistant. I don't know all of the varieties, but this group of about 11 beds going down the center, they're showing promising resistance and type perhaps, but I don't know exactly what's in there. So brief history of Fusarium wilt. There was some mention of it this morning and where it showed up first. So it showed up in Japan in the mid-50s and was a problem. They really started working on resistance breeding in the 90s, is my understanding of it, or they finally made progress in the 90s. And they used as their source of resistance a variety that you probably have heard of, the variety Salinas, released by USDA by Ed Ryder. We didn't know it had resistance. We were puzzled. There were people that had come over from their villages that were having trouble with Fusarium, and they'd ask us what we were doing for Fusarium resistance, and we said, we don't know. We've never had a problem with it. Although it had showed up in Huron. So Huron, 1990, Jim Garrick and Judy Hubbard published or found it in Huron, that swing district between the Salinas Valley and the desert. And then it seemed to go away, but it really didn't go away because growers there could rotate the different crops, different fields, excuse me. So they had that latitude. Then a few other reports in other countries, Iran and Taiwan, and in the late 90s. And then I think Yuma was the first, 2001 was the first year it showed up in Yuma, according to my notes, and it hit pretty hard. 2002 in Italy, there was a report out of there of the problem. So we started off with Mike, working with Mike and variety trials, and then we had wonderful visitors from Japan that brought some varieties over that they had worked with, and Fujinaga, who had been working on Fusarium for a long time, gave us the differentials, and we'll talk about that, race differentials. But 2002, Steve, you might not remember, we had a Fusarium trial in the Pajaro Valley, and we were out there with Tom Gordon, and the PCA came by and he said, oh, we've known this is here for a long time. We've been fumigating for the strawberry crop. So they were controlling it that way. So I don't know how long it had been there. And I don't think of that part of the Pajaro Valley is very warm, but so it was puzzling that it was there. And that was kind of a conundrum for us. In 2010, I put for Salinas Valley, I don't know exactly when it showed up in Salinas Valley because I would get reports that we would have it. And then working through the lettuce board, I tried to have trials down in the South County, and the grower would back out at the last minute. There was some concern of having, being associated with Fusarium wilt. But it's really come on strong. I just heard from too many people now. And we had a nice trial last year, actually, in the King City area, Fusarium wilt trial, and it was pretty hot there. So races, that came up. I think Isabelle mentioned it. There were a few questions. So we have 4 races that have been described. Isabelle mentioned race 4, and that's a fairly recent one. I think maybe 2 years ago in the Netherlands that was discovered. Race 1 was the first one. When we started working on it, there might have been a second race described almost at about the same time it showed up here. And the differential at that time was Costa Rica 4. They gave a seed of a variety called Patriot, and that's susceptible to everything that I know of. So I dropped it off the chart here. But Costa Rica 4 is resistant to race 1, susceptible to races 2, 3, and 4. I think to 4. Banchu Redfire, susceptible to race 1, but resistant to race 2. So that was described by Fujinaga. It's a Japanese variety. It has a beautiful red color. And then later when Fujinaga reported race 3, both of those lines are susceptible to race 3. So that was kind of our first set of differentials coming out of Japan. Based upon the reports from Japan, it didn't look like the races were emerging in response to the deployment of the resistance by the farmers. The races occurred in different parts of the country, separate. And if you understand the agricultural system there, they're distinct from. And in the report by Gallardi here, 2017, and this table's based upon some of the data in their report. They made the mention, they looked at a bunch of different molecular markers and mating types, and their conclusion was that the occurrence of different races are totally independent events, not in response so far to deployment of resistant varieties. So who knows what
the reason for that is. But that seems to be the picture. And that was, Fujinaga confirmed that when he was here at the 2015 meeting, because I wanted to know that specifically. So Costa Rica 4 is a good resistance source for a differential. So if you just grew Costa Rica 4 in your trial and it became susceptible, then you might be concerned that there's some differential. Banshee Redfire should be susceptible to race 1, and we've been a little concerned about that. We had some odd reactions, and maybe it's a mislabeled seed envelope or something there. But generally, it's been susceptible until the last year in Salinas Valley. So as far as we know, we're dealing with race 1 in California, in the Salinas Valley, and also down here. We've not seen anything other than that. And this goes back to the original Huron isolate and isolates that we've looked at here since that time. So that's the good news. It's stable, and hopefully nothing will change. Oh, you're right, Paul. There we go. Okay, so in the greenhouse, and Isabelle touched on this, that you want to go out in the field and work and select for resistance, but it's hard because you've got all sorts of other things. As Steve pointed out, he brought some new pathogens into the conversation that I hadn't been aware of. But Jim Garrick and Judy Hubbard, they described the methods that they were using, and we just copied those at Salinas. They were just in the same lab. And then we used this real simple disease scale, 1 no apparent disease, 2, 3, 4 down to Senest. And we've looked at different concentrations, and you can kill them outright if you overload it. But this seems to work pretty well. I don't know how it relates to the concentration in the field. So and Isabelle mentioned different sources. We started working with the Japanese material. We actually went in and looked at the pedigree of Salinas, and it looks like resistance goes back as far as Kalmar. So Ted Welch, when he released Kalmar with UC many years ago, it looks like there was resistance in there, and we didn't go any further than that. So there's been resistance to it around for a long time. It's in Salinas, but it's not as stable as it could be. So with the tests that Mike had a few years ago, well, early 2000s, lots of varieties tested. We looked at a number of those lines there, and we really liked Costa Rica 4. Salinas, maybe as I mentioned, has some level of resistance, and we really then started working on this cross of King Louis by Autumn Gold. Autumn Gold is a variety that was developed for the desert from a cross of Vanguard 75 by Empire. So it's got the Vanguard type, Salinas type. It's adapted to the early part of the season. But in 2015 at the meeting here in Yuma, Cabral and the lab that she was in, they reported resistance being dominant, whereas we'd been looking at resistance as being recessive. And so that was a little distressing. How can it possibly be that way? But it could be inoculum load. That's one possibility. You could change your resistance reaction, but I think there's really some different gene actions available in the germplasm. So Cabral, they're working with varieties in Brazil. So we made a bunch of different crosses, but as I mentioned, we focused on this King Louis cross by Autumn Gold. As I mentioned earlier, Autumn Gold is adapted to the desert and is a reasonable parent to start with because we already had the Vanguard type or the Salinas type. This is reactions of F3 families in 2010 and 2012, and this is in the Yuma area. We had some really good trials in those years. We couldn't get a trial every year, but you can see a real distribution. Again, the rating scale here is 1 to 4, and these are different plants going across. So some plants had a reaction of 1, no obvious symptoms, even at harvest time, and some things up here like Patriot are susceptible check that we like. Is here. Autumn Gold is here. You can see it's pretty susceptible. Although we've seen trials where Autumn Gold looked really good, and we'd say it must have some medium level of resistance, but then it gets hammered in the next trial. So who knows what's going on out in the field. I don't know what CO stands for anyhow. King Louis is right here. So it's pretty good, but not as good as some of the segregates that came out of the cross Costa Rica 4. This is the variety of the Japanese. It's sort of a semi-romaine type. They have a different type altogether. I think the BO is a Boss breeding line. I'm not sure who that. And Salinas is in there. You can see Salinas looks pretty good in this trial. 2012, you can see things shifted a little bit. Salinas is over here with Autumn Gold and Patriot. Costa Rica 4 is here. King Louis is here, and this is out of the same population. A lot of the F3s are in this material. So we felt pretty good that, in the field, and Isabelle talked to this, we wanted to select in the greenhouse, but we didn't really trust the greenhouse results there, because sometimes there would be misses, sometimes you'd overwhelm everything. So we liked the field, but we had pretty good agreement between the results in 2012 and 2010, and so we really liked coming down here and planting in the growers' fields, taking the data and then going back and into those families and then testing them in the greenhouse and moving them forward. So we had 52 F3 families that we advanced to the F4. Some of them sort of looked like iceberg, others were really segregating unexpected phenotypes coming out of that group. And this is an F4 population. You can see autumn gold way over here. It's extremely susceptible in this test. And again, this is in Yuma. Early fall planting. Salinas is here. Not looking too bad in that test from a disease standpoint. King Louis looking really good here. We had Costa Rica 4 and some F4 lines over here. They just didn't even pop up above the scale. So we felt pretty good that the resistance that we're selecting was holding up down here pretty well. This is an F5 test in Yuma. I think this might have been actually 4 years ago. We had the 2 tests here associated with the trial here. Here's Patriot. This is our susceptible. It wasn't highly susceptible here, but a number of plants dying. Costa Rica 4 is looking pretty good, pretty stable resistance. Salinas is not too bad in that test. Autumn gold, sort of like Patriot, but here's 4 of the F5s that were in one trial or the other, and they look pretty good. Again, one being no obvious signs of wilting. So a few plants maybe wilting, occasional plant perhaps kicking off in the trial. This is data from the trial out here this year at 50 days. So we'd like to look at it again. Maybe we'll come down in early December and take another data set. So we had autumn gold in the test here again. And this is the number of plants over 6 replications that we had. Autumn gold, a rating of 2.1. So some wilting, not real severe. I should show the graph, but I don't have that. El Guapo, Stephanie said this is kind of the variety that she likes as a susceptible, and it's comparable to autumn gold. But here's 5 of the 6 lines that we're ready to release here, looking very good. 3 of them with 1 ratings, others with just a little bit of disease in there, perhaps showing up. Let's see. Salinas Valley. This resistance holds up very well in Salinas Valley. This is a test. We had 2 tests last year in the King City area, and it gets warm down there, but it's nothing like Yuma in September. So Patriot, again, this is pretty hot in 2 tests, average of the 2 tests. Costa Rica 4 looking really good, so we feel good about that resistance. Again, confirms that we're dealing with race 1 in Salinas Valley. And this is the data on our 6 lines here. And I do have a flyer here and a sign-up sheet. So we've produced seed. We've sent seed to the plant. Oops, I lost something. Sent seed to the plant introduction station. So the seeds will be available pretty soon. We'll as soon as Barbara Hellier gets them up online. And if you want to pass that around, I've got a sign-up sheet. If you're interested, if you're a breeder or a seedsman and you want some of that seed, let me know and we'll send you the announcement. And then also, I have a copy of the announcement. So we're releasing these 6 breeding lines that you see here, 631 through 34, 669, and 670. So I don't know how long it'll take Barbara to get that into her system there, but they'll be available. Let's see. So you can see pretty good agreement between these 2 tests, and this is in Salinas Valley. This is what symptoms look like in that test, and as Steve showed, you get that distinctive red discoloration in the roots. This is Patriot here on the left, and these are roots from one of the breeding lines here, and they're pretty clean. If you look closely, you can see maybe just a little streak of red here. Maybe in this root too. Frank Martin, who's our Fusarium expert in Salinas, says that Fusarium is infecting everything. It doesn't matter whether you have a resistant variety or not. It's getting into every root. But there's some resistance mechanism that's being expressed here, and so the plants either are becoming susceptible and wilting occurring, or that's not occurring. So we know Fusarium is a general thing that it likes to infect everything, and you may get a little bit of that. This is what the material looks like. This is one of the lines. Again, it's got the Salinas type, Vanguard type in here. Some of the plants will form a reasonable approximation of a head. This is in King City, so these haven't been selected for adaptation to King City. And then some of them are a little more wild, so there's room for selection down the road by seedsmen. Again, release of these lines just pretty much reiterated what I have here. So seed produced this year, we had a terrible time. Steve talked about INSV. We had 4 different plantings, and I think 2 of the lines we met the minimum for Barbara Hellier's germplasm bank, and then the others we had either half or maybe about a third of the amount. She wanted 10,000 seeds roughly. But INSV in our greenhouses is just ravaging everything, and it's in the fields in a really severe way in the Salinas Valley this year. So we'll be growing out more seed and trying to keep the thrips at bay. And I know there's thrips down here. John Palumbo's done a lot of work with thrips, so INSV can't be very far behind, or it's got to be lurking around, you would think, here. But so acknowledgements, we had a lot of people helping out in the early days with the trials here, and then lots of folks in the staff in Salinas, and then lots of support from the industry, the boards and farmers as well. So with that, I'll take any questions that you might have. So the question is there a way to evaluate materials from the field and identify the race type? So our data suggests that we only have one race in the area. I don't know.
But there's several different, I mean, we talked about Santa Maria, we talked about Salinas, we've got 120 miles of desert here to farm medicine, and the potential for that. We're not just farming, a lot of us aren't farming in just one area, we're farming in multiple areas, and the potential for cross-contamination is there.
Right. Well, our data, based upon the differentials that have been established internationally, there's only race 1 in California and Arizona, Salinas Valley and here. I've just heard about Santa Maria. My guess is going to be the same, but we do need to look at it.
So we're seeing behaviors change within these things. I mean, Steve and I have talked about this before, and we see changes in the behavior, and we're seeing Fusarium show up in areas that haven't typically shown up in the past, and seeing behavior within the organism that's not consistent.
Right, yeah.
I think that's something that's important to consider. If you don't look for that, it's going to lack some type of data.
Well, we can certainly test it at Salinas. I'd be glad to do that. I don't know whether Steve's thinking along those lines and providing that type of service, but we can do that. I just received maybe 2 months ago, Patty, a sample from one of the local seedsmen in Salinas Valley, and he's with an isolate from around the Gonzales area, I believe. And we ran a test on that, and I think that looked like race 1 there, Patty. It's still underway. Okay, it seems to fit the race 1, but we can do that. So feel free to contact me, and we can run the tests in the house. It takes a little while. There's no molecular markers to identify the races yet. That would be nice to have, for sure.
As I understand it, you can't detect the race until you get a resistant variety. Is that correct?
Right. Well, as you can see from the slide on the races, we have resistance available for what it's that interaction between the pathogen and the host that defines the races there. So we've identified 4 races, and we have sources of resistance to those 4 races. So that's kind of where we are. So we can identify it with a grow out test or planting material in the field. Frank Martin at Salinas is working on markers for Fusarium. I don't know if he's working on the race aspect of it yet, because we don't. At least as a breeder, I haven't dealt with different races. Frank can get mitochondrial DNA in, and he can work with any of the races. So I'll have to touch bases with him on that. Tom?
Yeah, is there any kind of soil diagnostic tool to use to identify fields that have Fusarium in it that at a high enough inoculum level to cause disease?
Frank Martin is working on that. He's working with mitochondrial markers, and he's combined it with a kit, a product out of England, Twistix, I think is the company name. And so a farmer can go in the field, take some samples, and he can determine presence of Fusarium within about 15 minutes in his truck.
Steve might want to comment on that.
And Steve, have you been working with Frank on that?
Yeah. We're also doing soil assays now, plating assays to get an approximation.
Yeah, Frank is. So I didn't repeat. The question was, is there any diagnostic assays for that? So Frank also has diagnostic assays set up for Verticillium wilt. He's probably working on Pythium, because I know he's working on Pythium and maybe Macrophyllina as well. Yes.
So the other question I have for yours is, going back to, again, some discussions, is there any correlation between levels of pathogen in the field and the response to potentially being an issue?
I can just claim ignorance as a plant breeder. I don't know what levels. I know Tom Gordon's looked at levels in the field, and I don't know, Steve, you may have assayed levels. That's beyond my thinking, I guess.
Yeah, we'll get Tom on that, but we don't have a firm threshold. Like, verticillium on strawberry, we have a good idea of the level for significant disease and not. But we don't have that for Fusarium on lettuce yet.
Yeah.
I'm not aware of a firm threshold. We're doing soil testing to get a number, but that takes interpretation in terms of if it's important or not.
Yeah, so on your paper, you mentioned that Kingu's gourmet type leather has a highly resistant to
Yes.
So I was wondering, what are the defense mechanisms that each plant has shown? If you have to look at the molecular basis or anything that showed.
I've not done that. I've pretty much just straight plant breeding.
Just straight plant breeding?
So I haven't done that.
Any defense mechanisms that you think?
I don't even know where to begin as a plant pathologist. I won't go there. So hopefully maybe Tom or maybe Frank Martin looking at it. Richard Mitchell Martin might be looking at it also. His lab at Davis has also been working on Fusarium in the field there in Davis. The question was whether what the resistance mechanism is. So I haven't seen any reports on it, but again, that's far. So sorry.
Can I get one more question? Who was working on the markers, did you say?
The markers for Fusarium is Frank Martin. He's with USDA at Salinas.
Thank you.
In combination with TwistX product. That was for the soil enumeration. Are you talking about markers for just identifying the pathogen or markers in the breeding? We've had a little bit, there's probably something going on with Richard. I haven't had a good conversation with him, but a former postdoc who worked in our lab on verticillium, Herman Sandoy, is in Florida. And so we've got kind of a three-way collaboration going on, and he's really interested in identifying the markers. So in the public sector, at least that's about where we are. And there's a report out of Brazil on their material, and I can provide you the reference on that. I think they've got some markers for that source of resistance.
I have a question. Are there any studies being done on like soil texture and temperature and correlation with severity?
There's a question about soil texture and
temperature.
I think early on with the test with Mike, it seemed there was correlation with soil temperature. At that time, the disease was especially severe in the September plantings, and then as you went into the October and November plantings, then it just tapered off and went away. But I think I saw a table yesterday where we had some data. I had it labeled spring Yuma, which puzzled me because I didn't remember any tests in the spring. But it seems like higher soil temperatures have generally been associated with this, but there could be variants. You could have the same race, but with other differences that adapt that strain to a high temperature or a low temperature. As I say, we were puzzled that there was Fusarium in Pajaro Valley and Salinas Valley. Look at it, but the summers in Salinas Valley have been warmer recently. And so but not anything like down here. Steve.
Yeah. So Tom Gordon has done a lot of work on the temperature. He's published that. So if you let me, I can get you that report. I don't know anyone who's done soil type.
So no soil type.
No soil type, but temperature, yes, that's been defined pretty well.
So I have maybe just a comment or a question in response. For the desert, it seems like the Fusarium is a problem in Yuma, but not in Imperial. Is that true? Because the soils, I think of the soils as being quite different in the Imperial Valley in general. Heavier clay loams, whereas here it's sandier, but there seems to be plenty of clay in our trial. It did not be able to go out. So it seems like there's some association with the soil, but Salinas Valley, I've been told there's Fusarium in the Blanco district, which is a good heavy clay, as opposed to the lighter soils here in Salinas. So I'm not sure that soil type is really a factor.
Imperial also starts like 10 to 15 days later on their iceberg than we do, most generally. So that could also be a factor in why you see more here compared to there.
Right, yeah, but it does occur in Imperial? Does anybody? Yeah, okay. I just haven't heard it. Excuse me, heard it.
Okay. Thanks, Jim. It sounds like people might have a few more questions for Steve too, so maybe when I'm done, we can go back and open the floor for some more questions if anybody has any more. So I am going to talk about a little more than what we were going to show you in the field if we were able to go out there. So I'm actually able to tell you a little more and show you some pictures that Rosa went out and took for us. We're continuing Mike Matherin's field trials. This is the 5th year, right? The 5th consecutive year, because there were some trials in previous years. And first I want to let you know that there are people working on Fusarium Wilt at the University of Arizona. Mike is retiring. I said at the end of the year, but it's the end of the month.
No, year.
Okay, end of the year, good. Is Alex here? No? Dr. Alex Hu, he's an extension specialist located in Tucson. He is doing some research on Fusarium wilt of lettuce. Dr. Bindu Pudel, she has the diagnostic lab here. Steve was talking about the importance of diagnostics. You can send your samples to Dr. Pudel. Barry Pryor, I spelled his name wrong, don't tell him. He is doing some work on Fusarium wilt of lettuce. So there are active research programs. These are 3 plant pathologists that are involved in Fusarium wilt. And there's also researchers in California and Florida. Jim talked about Frank Martin. We've been working with him a little bit, and I actually have a grant application in that involves Frank and also Herman Sandoya, who Jim also mentioned, who's a breeder, and he's interested in screening the USDA lines and looking at some of the markers for resistance. So there's an active there's active programs, and we're also discussing putting together a Fusarium wilt working group so we can coordinate efforts and coordinate research ideas. Okay, so for our trials, we had a few objectives, and some of these were the same objectives. Most of these were the same objectives as previous years. We want to screen breeding lines. We want to see what resistance is out there or soon to be available. Want to look at some crop protection products. We know these are not the answer to Fusarium wilt, but they could be helpful. And we also want to see what's out there, what's available right now in commercial breeding lines. So there's quite a few varieties out. Sorry, I didn't mean breeding lines. Commercial varieties. There's quite a few commercial varieties out there. Some people think that they're seeing some resistance. We wanted to be able to compare them and see what the resistance looks like in the field when you're comparing them one next to the other. We're also looking at some soil quantification. We're working with Steve to look at soil populations. We want to look at the distribution of the pathogen in the field and what that means. You know, we talked about, somebody just mentioned thresholds. It's going to be hard to determine what these populations mean. Soils are different. You know, you have different levels of organic matter. You have different. There's many factors in the soil that will change what the threshold is. And this project is funded by Arizona Department of Ag Specialty Crop Block Grant. Okay, so we have 2 sites. One of them is in Welton. We planted that very early on September 4th. And the night of September 4th, some of you might remember it rained. So we had some not so great emergence, and that field is pretty heavily infested. So it's a pretty severe example of what can happen with Fusarium wilt. We have a second site in the South Gila Valley. That's where we were going to have the field day. And in both of these sites, we had a really great planting crew. We had some of our own people, and then Keith Lee Williams Seed sent out a great group. And we would have been planting this trial for 2 days if it wasn't for them. And also, I put this picture up here because Fatima was just amazing, helping me for months. And then, of course, Matt. But Fatima and I were talking just constantly about planning these trials, and I want to make sure I properly acknowledge all the help she gave me. And here we have with the JV Farms crew was great. And that was planted on September 18th. A little better weather. We did not have any rain. We had really great emergence, and I think that trial looks fantastic from a plant pathology standpoint. I'm a plant pathologist. I have to admit that. Okay, and this is just our crew. So this is YCEDA, and this is also, we had some U of A people helping us. Martine was fantastic helping us with this trial. And I'm sorry to bore you with all this, but I'm so grateful to all these people. Okay, so to start with, we have this breeding line trial here. So we have, in this trial, we have lines from 2 public breeding programs. So we're working with Jim. We're also working with Richard Mitchell-Moore. So we have quite a few breeding lines in there that are looking for sources of resistance to feed into breeding programs. And then we have 5 private breeding programs. And we had 320 plots total. Actually, I'll describe that in a second. The purpose of this is to help to speed along the release of either new sources of resistance or helping these breeding programs get things into the market faster. So we want to help people collect data and let them know how their lines are doing or their varieties are doing. We can go out there and do a number of evaluations and give some good data back to these companies, and our hope is to speed things along, get things in the market to you to plant. We have, what I did for this trial is I set them up in small plots, so we don't have to worry so much about the distribution of the pathogen in the field. We have these nice small plots. They'll most likely have similar distribution. I'll show you some pictures in a minute that might make you question what I just said. But so we have quite a number of plots, 320 plots. We have 4 to 16 replications of each variety or line in this trial. We will hope to engage more breeders for the next set of trials. We hope to continue this year after year and continue to help these breeding programs. And my request to you is, I know a lot of you know where this is. We want to help protect IP, so please don't go into this field. Let us get the confidence of these breeding programs, continue having confidence from these breeders, so they'll let us plant their lines. Okay, so here is what I was just talking about. This is one of my blocks. It's a nice small block. These are about 15-foot plots, so it's 30 by, I don't know, let's say 35 by 35. It's a nice block. And there's some good-looking stuff out there. I can't tell you what it is, but because I don't know what it is. A lot of these are just numbered, but there's some good-looking plants out there. A lot of stuff got completely wiped out. Well, some stuff got completely wiped out, and some stuff looks really great. So I think there's a lot that might be coming through the pipeline in the next few years. So I'm pretty excited to see this. Okay, so we have a crop protection product trial, and this, we know that crop protection products, they're not going to solve Fusarium wilt, but they might help to maintain resistance. So if we have a resistant or tolerant, highly tolerant lettuce variety, it's possible that there might be some crop protection products that can help to support that, so to reduce the disease pressure, and so we'll have that variety around for a lot longer. We're working with a couple of companies that are developing new products. We're also, we have Serenade and Vellum in there, and Vellum I know is not, I'm fairly certain it's not registered for lettuce, but we decided to try it out. We have a high CFU Serenade and Zincicide, which I don't think any of you know about, but it's a product that's developed by a colleague of mine that I worked with when I worked with the citrus industry, and it's an interesting new product that has worked pretty well for other fungal diseases, so we're going to see if it works for this. It's still years away from being available, but it's something that could be useful in the future. So there's 14 treatments total, and what we did was, because Highly susceptible variety might just go down and we'll see no differences between treatments. We planted we repeated the whole trial, once on El Guapo and once on Meridian. And so what you're seeing right here, this is Meridian, not so bad. I do want to mention that you see this side of the field, and it looks like, if you just eyeball it, it looks like these treatments might be doing better than these treatments. That's the distribution of the pathogen in the field. So here's the El Guapo. You see this really interesting pattern. There's obviously a uneven distribution in this field of the pathogen. And one of the things we're looking at is soil infestation rate. So we're working with Steve, and we're estimating propagules per gram of soil. This is just an estimate. And we're getting pretty wide distributions of the pathogen in the field, the propagules in the field. So I did an average of the 16 samples that we had the results we got back from Steve, and it was about 226. That was the average propagules per gram of soil. So that's a spore, or it could be a piece of mycelium either, but most likely it is a spore because this was dry soil and it had not been planted with lettuce since the previous season. But the standard deviation was 164, which means it had a wide distribution of propagules. So we had, in the 40s, and we had in the 400 range. So, but that's within a large area. So we have some samples that we just sent to Steve. They are smaller areas, so it's a 20 by 20 foot plot. And we'll be able to get a better resolution of what the propagules in the fields look like. That doesn't mean we'll know about thresholds. That's a long-term project that we need to start thinking about, or we need to start doing something about. So next time you hear me talk, hopefully I'll have some information for you on that, and I'll also have some results from this trial. Okay, so what we were going to show you today was this commercial seed variety trial. So we want to know, how do these varieties perform next to each other? And I've talked to lots of you, and I've heard, oh, this one seems to be doing pretty good, and this one's not doing so good. And everyone has a different idea of what they think has done well in the field. And so I just wanted to put them all side by side and see how they perform next to each other. So what we did, these are so this is 300 feet, this is 300 feet. We did, it's a replicated complete block trial with 4 300-foot block plots per variety, and it is 1 row per variety. And we did not pick varieties that the companies had made a claim that they were Fusarium Wilt resistant. I talked to some of you, and I asked you what you thought had some resistance. So, and some of them I had a list, and I just picked the ones that it was easy to get as well. But they all were on that list of what was had the higher level of resistance according to you. This is a high disease pressure field. You see that here. I mean, that's not what you want your field to look like. So this is a pretty high disease pressure field. So we put these in stressful conditions, and they were planted September 18th. So we really put these through a lot. So you can see here, this is not the prettiest slide, but it's what I could put together at 9 o'clock last night. So you can see we got a variety of results. Some things did pretty good, some things did not so good. El Guapo was our control. That one has gone down pretty consistently in this field and in our Welton site. And then we put Meridian in there because it's shown pretty good resistance over the past few years. We want to continue this trial. We want to do this yearly. If it's of value to you, you have your survey that we passed out. If there's varieties that you're interested in, put them down. We want to know the top 3 varieties that you'd like to see in this trial, and help us make the decision, because I don't want to decide what to put in this trial, or I don't want just 1 or 2 people. I want all of you to have a say in what we evaluate in the future. Also, the survey, we want to learn more about what you're seeing in the field with Fusarium. So if you can just take a few minutes before you leave to fill that out, I'm going to share that with Cooperative Extension, and we will be able to understand better what the effect of Fusarium wilt is on you. Okay, and we will schedule a time to visit this field trial in early December. I will go out in the field, I'll sit there for a couple hours. Whoever wants to come by, I'll give you a field map, let you walk through. So don't forget to put your email down on that list when you came in and when you signed in, and you will be emailed the time and date for that. This is our trial. Let's see, so here's the variety trial, here's the crop protection products, and here is this is the commercial varieties. Oh, here's commercial varieties again. You can tell when we hit the end of the block because the meridian here ends. So meridian here, El Guapo here, and here's our second set of plots for our variety trial, our commercial variety trial. So you can also see the patterns in the fields of the pathogen. Okay, here's our variety trial. So here's one block of that. And you can see some of these look really great. There's some romaine in here. There's just a couple of romaine. There's some red leaf. That's part of the Michelmore lines. This is probably El Guapo here. We had a control in every one of these blocks. We had Meridian and El Guapo in every one of these blocks, so we can compare every plot to those two. They're not exactly controls, but they were our. The El Guapo is more of a control than the Meridian. So there's some pretty good looking lettuce in there, so something to look forward to. Here's our commercial varieties again, crop protection product, and our variety trial. Okay, so something else that I'm doing in my role at the Yuma Center of Excellence, I'm working with researchers to develop more research to help you with Fusarium wilt. So some of the things we're doing, we're looking more at soil quantification methods. I've talked a lot with Frank Martin. We're trying to find ways to get the tools that he's developed to you, and also start thinking about how to develop thresholds. So it's going to be challenging to develop thresholds, but maybe we can get some general guidelines. And so when you have the ability to test how many spores per gram of soil you have, you can decide what varieties of lettuce you want to plant. We want to look at the population structure, so that is race, but also, are there changes in the population that make this pathogen more or less virulent? Soil disinfestation methods, so the Fusariums, if you have Fusarium in your field, it's there to stay, but there might be ways to reduce it and keep those populations below that level where you're having severe crop loss. So there's things like biosolarization, which is a combination between solarization and something called anaerobic soil disinfestation. I won't go into that because we haven't worked it out yet, so you don't want to hear about it at this point probably. Biofumigation, so use the mustards to reduce populations. Alex Hu is really interested in this project, and we have actually both of these methods in a grant application that's out right now. Also, suppressive crops, other crops you can grow that'll help to reduce the population, and how do you use those to remediate your fields. Also, this is more in the soil health category, but improved soil health will help suppress disease severity. Maybe not in a field like the field we're working in Welton. That would probably need some soil disinfestation, but soil organic matter, a healthy microbial community, that will help to suppress disease. So that, I think, is a more long-term research project, but just keep that in mind. And of course, we want to continue looking at resistant varieties. We want to work with new researchers like Herman in Florida. They have a Fusarium Wilt problem now, so there's the opportunities to collaborate and maybe integrate some of the varieties that he's developing or the sources of resistance that he's trying to identify into some desert lettuce varieties. And of course, keep on looking at crop protection products. Okay, so again, there's that Fusarium Wilt survey that's that you were handed that out when you walked in, and there's also the variety. Let us know what varieties you want to see. Thank you so much to all these guys, and these people helped us get some seeds, and so many people were just so helpful. Jim and Patty came and dropped off some planters for us and taught us how to use them, and there are so many people involved in these trials. Thank you.